Hey, hey. We are going to go ahead and take a look at section 1-8, interpreting graphs of functions. Now, this is on page 56 in your book. So if you don't have your book right now, just go ahead and pause the video, go grab your book, and see if we can work at this together. All right, so we're going to be working on example 1, interpreting intercepts. If you look in your book, on the right side of that page 56 is this graph. If you see this graph, then that's good. All right. So the graph shows the height in y, and the height is measured in meters. All right. So every 10 meters, if you notice, it's every 10 meters. So 10, 20, 30, 40, etc. In y of an object as a function of time, x. Time is x, so it is the x-axis, and is measured in seconds. So starting from 0, 1, 2, 3, 4, and etc. So every 1 second. What they want us to do is identify the function as linear or nonlinear, then estimate and interpret the intercepts. All right. So let's first identify the function as linear or nonlinear. In order for it to be a linear function, it would have to be a straight line. Now, since this is a curved line or a curved graph, it is not a straight line. So we'll call this nonlinear. All right, so our answer would be nonlinear. All right, so let's go ahead and find the intercepts. Okay? Now, the x and y intercept, it should be relatively simple to find, just because if we look on the graph and wherever the line or the graph itself touches either the x or the y axis, that would be the intercept. So for the y, all right, the graph itself touches the y right here at this point. So this is considered to be the y-intercept. And the y-intercept is between 10 and 20. So we'll say halfway between 10 and 20. The y-intercept should be at 0, because 0 would be x, and y would be 15 as a coordinate. So the y-intercept, should have written this down, is 0, 15. Now the x-intercept, we're looking on the x-axis. So on the x-axis, the graph touches that line at about here. All right, so it's between 7 and 8. So that point 7 and 8. We'll say it's halfway, but it's kind of less than halfway, so we'll call that 7.4. So for the x, if we were writing down that coordinate, remember x is first, 7.4. Sorry, I put 5. But 7.4 would be it, and 0 for y. All right, so about 7.4 and 0. So here's my y-intercept, 0, 15. And remember, our coordinates are written in x, y. So x is always first, y is second. And my x-intercept is 7.4 and 0 for y. Okay? Now what we're going to do is interpret the x and the y-intercept. So in interpreting the function x and y, first of all, let's go ahead and interpret the y-intercept. Now, what the y-intercept means is that the object started at the initial height of about 15 meters. So from the launch, it started at about 15 meters. Okay? So let's go ahead and write down what the x-intercept says. So the x-intercept means that if and when the object is launched in the air, it hits the ground or lands at about 7.4 seconds from launch. All right? So this was the x-intercept. When it started at this point, it went up, and maybe the person threw it, or maybe it's actually a rocket, a small rocket, launched up, and it took about 7.4 seconds to actually land from the time it launched. All right, so let's see if we can do one on our own. And what I want you guys to do is find out if this is linear or nonlinear. Tell me the x and y-intercept. Interpret the intercepts. Okay, so what I want you to do now is just pause the video, answer the question, and just go ahead and click back on the video to see if you got the right answer. All right. Let's see if we can get the right answer. So, first of all, we have to tell whether it is linear or non-linear. Now, because this graph is a straight line, this is considered a linear. So this is a linear graph. All right, so let's go ahead and find out where the x and y intercepts are. Now this is a little tricky. If you're looking at this, then this line right here, then you'll be wrong. Okay, so don't look at this line. Let's look at the actual x-axis, which is here, and the y-axis, which is up and down. All right, so on the y-axis, we see that the line intercepts at about right here. Now it looks like it is in increments of 5, so this would be for the y-intercept. This would be 0 for x and -5 for y. All right, 0 and -5 for y. Now for the x-intercept, we're looking at this line, just that line itself, and it crosses or touches the x-axis at about this point right here. All right, so it looks like it is in increments of 1, which is in hours, so this would be 1 hour, 2 hours, 3 hours, 4. So x-intercept is at 1, 0. Okay, now let's go ahead and interpret what this means. All right, so for us, we know that since the y-intercept is at -5, that means the temperature let's write this out. So the temperature was about -5 degrees at the beginning. Well, that's not how you spell beginning. Was about -5 at the beginning. Okay? Now, the x-intercept just simply means that at about, means that after an hour, we'll say the x-intercept means after an hour, so after 1 hour, the temperature was 0. (0°), and this is in Celsius. Okay? Hopefully this helps. If you have any questions or comments, you can feel free to leave those comments down below. I left it open so that you guys can go ahead and leave the comments, or if you even have any questions, just go ahead and leave it below. I hope this helps.